For the rest of this packet, they're going to actually give us a point and a line or some other combinations and ask us to find a new line that is either parallel or perpendicular. So let's go ahead and see if we can figure this out. And it also says to put them in point, slope, and general form. Okay. So passing through this point and parallel to the line y equals 4x plus 1. So this is y equals mx plus b, which means the slope of line 1 is 4, right? That's the number attached to x. If I'm looking for a parallel line, it has to have same slope. So the slope of my line is also 4. And I have a point that it goes through. So I can use point slope formula, which is y minus y1 equals m times x minus x1. So let's plug in. So I have y minus 2, m is 4, and then x is 1. Okay. So that's point slope. Now I want general form, so I'm going to solve this for y equals. So I'll distribute the 4. Then I will add 2 to both sides, and that'll give me y equals 4x, and then negative 4 plus 2 is negative 2. That's my equation for the new line. All right, so let's take a look at another one. So what's different here between the previous example? Well, we're still looking for a parallel line. We're still told that the line we're looking for goes through this point. The difference is that we're given this in standard form, right? And again, this doesn't happen often, but if that's the case, then we need to get this to be y equals first before we can continue. So let's start with that equation. 4y plus 2x plus 7 equals 0. Now I want y by itself, so I need to get both of these terms to the other side of the equation. So to do that, I need to subtract both of them. And if you don't like me doing this in one step, then do one at a time. It'll still work out the same. Right, this cancels with this. This cancels with this. And I get 4y equals minus 2x minus 7. Now I want y by itself, so I need to get rid of the 4. So I'm going to divide both sides of the equation by 4. 4 divided by 4 is 1. So I get y equals. And on this side, I'm going to separate this into two fractions. This is going to be minus 2/4 x minus 7/4. And negative 2 over 4 reduces down to minus 1/2. Okay, so this is line 1. All the information we need from this is the slope. So the slope is minus 1/2, and that's for line 1. If we are to be parallel, we need same slope. And so that means the slope of line 2 is minus 1/2. So we can use our point slope formula, plugging in the point that was given and the slope that we just found. Okay, so this is going to be y minus 4 equals minus 1/2 times x minus a -3. Okay. And then we just need to simplify this and get y equals. So this is x plus 3 inside. Then I need to distribute here. So I'm going to get, oops, minus 1/2 x minus 3/2. Last step is to add 4 to both sides. And then I need to simplify that constant. So right now I have minus 3/2 plus 4. I can put these two things together. I need to turn 4 into halves, which means I multiply by 2 over 2. So this is minus 3/2 plus 8/2, which if you put them together now, it's like this. And that gives me 5/2. So that means, and by the way, the arrow that looks like this means implies in mathematics, y equals minus 1/2 x plus 5/2. That is the equation of the line that passes through the point -3, 4, and is parallel to the line given. Now, if you'd like to check, right, obviously we know they're parallel right off the bat, as we see that they have both -1/2 slope. That means that they are parallel. They have different y-intercepts. Okay, so they're not the same line. And the only other thing we might want to check to make sure we did everything correctly is we can plug -3, 4 back into the equation just to make sure that it works, right? To make sure that we found the line that passes specifically through that point. So let's just do that just to double check. Okay. So y is equal to 4 and x was equal to, it was -3. Yes, -3. Okay. Okay. So -1 times -3 is 3. So we have 3/2 plus 5/2. That's 8/2, which is equivalent to 4. So indeed, this equation does pass through the point -3, 4. So this is the equation we were looking for. Okay, let's move on to the next example. All right, what's different here? This time, we are looking for perpendicular lines. So for perpendicular lines, slope is opposite reciprocal. Another way to write that would be that the slope of the new line is -1 over the slope of the first line. Okay? So the first line here tells us that its slope is 4. Therefore, our slope for the second line, which is perpendicular, has to be -1 over that, or -1/4. Right? That was flipping the fraction over and taking the opposite sign. So this is the slope of our line, and this is a point that our line must go through. If we have a point and a slope, we can use point slope formula yet again. So it's just a matter of plugging in and getting a y equals equation at this point. So I have y minus 2 equals -1/4 times x minus 1. Distribute the -1/4. we have this. I need y equals, so I'm going to add 2 to both sides. And then again, I have 1/4 plus 2. I need to put that together. That's 1/4 plus 8/4 or 9/4. So our equation is minus 1/4 x plus 9/4. Actually, let me just go to Desmos and just prove that these two lines are perpendicular. All right, so I've gone to Desmos here. I put our two equations in, 4x plus 1 and negative 1/4 x plus 9/4. You can see very easily that these two lines cross at a nice 90-degree angle, and therefore they are perpendicular. So that all looks good. Let's go ahead and hop back over and do another example. Right. So here we have an equation passing through a point perpendicular to another line. They did not give us this line in y equals form. We've already calculated this, so I'm going to go back up and just steal our y equals equation. Right, we had the exact same equation before, and we got that the equation needed to be y equals minus 1/2 minus 7/4. So let's just bring that back down here with us. Okay. So that's the original equation, the one that was given here in slope-intercept form. So that means that the slope of the first line is minus 1/2. If they are to be perpendicular, we need the opposite reciprocal slope. So m2 must be minus 1 over m1. So that's minus 1 divided by a negative 1/2. Negative and negative makes it positive. And dividing by a fraction, remember I can flip and multiply. And I just get 2. Okay. So my opposite reciprocal is now 2, which means I have the slope of my line. I have a point that it goes through. I can do point slope formula. So y minus y1, which is 4, equals the slope 2 times x minus a negative 3. This is really x plus 3 in here. Distribute the 2. Okay. And then finally, I need to add 4 to both sides. And it looks like I have this as the equation of my line that should be perpendicular. So again, let's go ahead and hop over to Desmos. So I need the line y equals 2x plus 10. That's the one we just found. And this line was minus 1/2 x, I believe minus 7/2. I'll double check. Yep, minus 1/2 x, I'm sorry, minus 7/4. But as you see, it doesn't really matter what my intercept is if it's still perpendicular, right? Because the slopes are opposite reciprocals. So it actually doesn't matter that this is 7/4 or 7/2, right? It's still perpendicular. Okay. All right, I believe that was the last example. Okay. So again, as always, let me know if you guys have questions.